right, as we get started today, we're going to begin with a speed drill. So get your speed drill booklets out and open to speed drill number 6. It's at the bottom of page 3. You may want an extra sheet of paper to work these through. So some addition, subtraction, multiplication, division. If you can work them in their already written state without recopying, water bottle on the floor there, Bryson, that would be great. But if you need the extra paper, it'd probably be good to have that readily available. You're going to have 2.5 minutes to get as many of these problems done as you can. There's one problem I'm looking at that is super easy. So, don't have to go in order. Do the easiest ones first, and you may begin. Stop. All right, put your pencils off your desks. Pencils off your desks. Just have out a pen. And exchange with the person behind you, person in the back. Bring yours to the front. Exchange with the person behind you, person in the back. Bring yours to the front. It doesn't require talking. Yes, ma'am.
Do we give them the paper we worked on?
No, we're just looking for the answers. Yep. All right, sign your name at the bottom of the page as the grader. There's not a lot of room down there, but there's enough to sign your name. So in pen, sign your name as the grader. Now the good news is there are only 8 points each this time because there's 12 of them. So you get 4 free points just for taking the test. Thank you for showing up today. And they're only 8 points apiece. Let's go across the top row, and I'll read each answer twice. Again, if it's incorrect, just put a slash through it. If it's right, don't put anything at all. Number 1, the answer is 84. 84. Number 2 is 325. 325. Number 3, 571. 571. And number 4 was the easiest one on the whole thing, 880. Stick a 0 on the back of the 88. 880. The next row going across, number 5 is 158. 158. Number 6 is 233. 233. Number 7 is 62. 62. And number 8 is 1,544. 1,544. Bottom row going across. This one wasn't actually very bad. It was a division problem, but it was pretty easy. 304. 304 for number 9. Number 10, if you think $5, how many quarters would it take to make $5? You might get 20 pretty easily. Though, admittedly, how many times 25 go to 52? How many times 25 go to 0, 0, 20? It was a pretty easy problem also, I thought. 20, our answer for number 10. Number 11, 764. 764. And number 12 is 292. 292. All right, they're 8 points each this time. So if they missed one, it's a 92, not a 90. So minus 0, of course, is a 100. Minus 1 would be a 92. Minus 2 would be an 84. Minus 3 would be a 76. Minus 4 would be a 68. Minus 5 would be a 60. Hopefully you don't need to go further than that. But figure 8 points each. Total number wrong times 8, subtract from 100. Put the score in the score blank, and then also remember, put it on that score page next to where it says Speed Drill 6. Once you got the score, put it next to where it says Speed Drill 6. Question, sir?
What did you say minus 5 again?
Figure it out. 5 times 8, and then subtract that from 100. All right. I will obviously go back and rescore these as well, so if there's some concern there, it's all good. For now, if you're at the front of the row, pass it, take it to the back. Everyone else pass it forward back to the owner. This one, Benjamin, hush. This one, it was a tall order, 2.5 minutes for that. So were there, though, any hundreds? Did anyone make it? Wow. How about 92s? You only missed one. That still would be really impressive. I'm pretty pleased with an 84, to be honest with you. How many 84s? Got a couple? 76s. 76s. Good. All right. Pass those forward. Pass those forward. Efficiency in math, because mathematicians are lazy. We want to be as fast as we possibly can be. Just pass them forward. I'll be regrading it. So if there's some issue, like, I don't think they graded it right, it's okay. I grade them anyway. All right. So pass those forward. And take your homework out. Books open to page 46. Books open to page 46. We began yesterday looking at a way to represent a part of a group. To represent a part of a group. For instance, if we wanted to represent how many of you forgot to pass the speed drill booklets forward when we collected them just a moment ago? Well, we would say one person out of 11 forgot to pass the booklet forward. We will name no names to protect the guilty. But that would be a part of a whole. Class, the way we represent a part of a whole is by writing a fraction. That was pretty weak, but I'll take it. Fraction. The top, thank you. Delayed reaction, better late than never. The top number in a fraction class is referred to as the numerator. And the bottom number is called the denominator. Good. And the key is, normally a fraction should have a smaller number on top and a bigger number on the bottom, because that's naturally intuitive how we think. We figure if there's 11 of us in here, the most of us that could do or whatever would have to be 11 of us, 11 out of 11. Normally, the top number would be smaller. If it is class, we have something called a
improper fraction.
Proper fraction. If the top is smaller than the bottom, class, it is a proper fraction. If somehow 13 of the 11 students were late to class, we don't know where the other two came from, but 13 of the 11, well, this class, that doesn't even make logical sense. This would be an improper fraction. Maybe if there were a couple study hall students in the back or something, maybe that would be 13 of the, I don't know. Anyway, and normally we wouldn't leave an improper fraction. We would say that 11 goes into 13 how many times completely, class? 1. With how many left over? 2 extra, if you will. And we put those 2 extra over the original 11, and we change our improper fraction oftentimes into something called class A, mixed number. It's got the whole number and a fractional part. You were starting with just identifying what types of things we had on numbers 1 through 4 there on page 46. Number 1 is what, Sam? Page 46. Improper. Number 2, Bryson. Improper. Number 3, Luciana. Proper. And number 4, Corey. Mixed number. Very good. Numbers 5 through 8, you were changing, like we just showed a moment ago, those mixed numbers, or improper fractions rather, into mixed numbers. And what did you get, Jalen, for number 5?
I got 4 and 3/8.
4 and 3/8 is correct. Number 6, what did you get? Paige.
22 and 1/2.
Excellent. Not 22 and 2/4, though it's not wrong necessarily. Minus a point, though, for not reducing. But 22 and 1/2, I like that she reduced. How many also remember to reduce? Be honest, how many left 22 2/4? So remember, got to reduce that fraction part when you get to the end. How about number 7? What did you get, Griffin?
9 1/6.
Excellent job. 9 1/6. The number 8, what did you have, Elaine?
16 4/5.
16 4/5 is correct. Any questions on 5 through 8? Do we need to see any of those worked out? How many got all of them, other than maybe the reducing thing, you got all of them right? You feel really good about changing improper fractions to mixed numbers? Any questions at all? All right, let's go to the other way around then. There will be times, I'm going to look at this tomorrow, probably in the lesson, where we'll have to sometimes change mixed numbers back into improper fractions. And obviously, if I wanted to reverse the process and go this way, I just multiply the 11 times 1, and then I'd add the 2 more to get my 13 over 11. So when we did that on number 9, Ben, what did we get for our improper answer?
14 over 3.
That's correct. Good job. Number 10, what did you get, Kirsten?
61 5.
61 fifths. So 14 thirds, 61 fifths. Number 11, Michael?
58 over 7.
58 sevenths is correct. And number 12, Ben? I'm pointing over here. Ben's over there. You're Sam. Hi, Sam. Good to meet you. I'm Mr. Nadaski. Sam, what did you get on number 12?
140 over 10.
Well, don't forget to then add the 9 on as well. So
Yeah.
10 times the 14 is 140. Add the 9 more to get... There we go. 149 tenths is correct for number 12. Did anyone go 4 for 4 on 9 through 12? Are there any questions on 9 through 12? Do we need to see any of those worked out or have them explained? All right. Numbers 13 through 16, we were changing to equivalent fractions, and they preset what denominator they wanted you to use. Number 13, they started you with 2/3, but they said, no, we need a new fraction, and the denominator has got to be a 36. What was the new fraction, Bryson? 24 36 is correct. Number 14, by the way, you're like, wait, Mr. Nadaski, wouldn't that reduce? Yeah, to 2/3. The whole point was we're unreducing here. So, yeah, of course it would reduce. Number 14, 6 sevenths. They want you to get a new denominator of 21, Luciana. 18 21st is correct. Number 15, they started you with a 5/8. They want a denominator of 48, Griffin. 30 48 is correct. And number 16, this was a toughie. They had 2/5. They want a denominator of 105, Kirsten. 42 105ths is correct. How many got all of those right? 13 through 16. Are there any questions on any of those? Do we need to see any of those worked out? All right. Number 17 through 21, we're reducing fractions to lowest terms. Remember, trying to divide the greatest common factor out. Or, if you can't think of it, divide something out. And then check and make sure before you circle the answer, is there anything else I could divide out? What did you get for number 17, Paige?
4 9.
4 9. Number 18, what did you get, Ben?
7 11.
7 11s. How about number 19? What did you get, Michael? 1/3. Number 20, Jalen.
2/3.
And number 21, Elaine.
1/12.
1/12 is correct. So 4 9s, 7 11s, 1/3, 2/3, and 1/12. Your answers. How many got all of those correct? 17 through 21. Excellent. Any questions on any of those? Sort of question? No? Yes? No? Okay. All right. Number 22. You were supposed to find the GCF of 20 and 50. And then you were supposed to find the LCM. Well, remember the key to finding GCF and LCM, class. First, we have to list out the, specifically the prime factors. Class, you got to list out what? Prime factors. So let's quickly prime factor 20. I'm going to have Corey help me. 20 easily splits into
2 and 10.
and then the 10 splits into
2 and 5.
so we would say that the prime factors of 20 are
2 times 2 times 3.
and then for the 50, a good way to split the 50 might be what, Paige?
10 and 5.
And then we could easily split the 10 into
2 and 5.
so we would say that the prime factors of 50 are
2 times 5 times 5.
2 times 5 times 5. Now admittedly, class, these are easy numbers. You might have seen the GCF without actually having to do this. But technically, class, when we're looking for the GCF, we're looking for what they share. What is a match? Well, what matches, class? a pair of 2s,
And a 5.
and a pair of 5s. So if their matches are a 2 and a 5, then the GCF class is 10. And most of you probably could have guessed or figured out 10 even without doing the prime factoring. But it's good to get into practice of it, so that way if we have harder numbers, we know what to do. Now for the LCM, I don't care what they share. Right. I want to know who the winners are. And we're going to cross out the losers. The winner of the 2s class, 20. These 2 2s beat that 1 2. And the winner of the 5s, 50. These 2 5s beat out that 1 5. So for the LCM, we're going to multiply 2 times 2 times 5 times 5 to get class? 100. And how many had 100 for that LCM? Good questions on GCF LCM. So I want to make sure we keep those skills sharp. And number 23. That thing's a doozy. Brave volunteer to tell me what you got for number 23. I've got some very enthusiastic hands. I haven't heard from Luciana in a little bit. Luciana, I'm going to give you first crack at it. What'd you get?
18.
That is not correct. Ben?
30.
No. Jalen?
21.8.
No. 20. How many had 20 like Kirsten did? 4 of you. Outstanding. Let's take a look at that one, because that is a great, big problem. Aren't you glad you didn't have anything quite that big on your test? All right. Some of you are like, extra credit? Could it be extra? All right, bonus problem, Mr. Nadasky. All right, so we have a 2 squared plus a 14 raised dot. What does raised dot mean, class? Times 2 minus 13 plus, and then we had 9 minus 2. Now the 2 is up against the parentheses, class. What does it mean when something's up against parentheses? Multiply over a fraction bar 5. All right, so in order of operations, the first thing we got to take care of, class, are? No, before exponents. Parentheses and grouping symbols. Well, I have a grouping symbol. But within this grouping, I've got another grouping symbol. So let's start right here with the 10 minus 8, class. 2. I'm just going to scribble it out and put a 2. Now, within this grouping symbol, I have a subtraction and I have a multiplication. Do I subtract first or multiply first, class? Multiply. Check your work. Did you get a 7 times 2 is 14?
Yes.
No.
Divided by 5 gave you a 2.8.
Yeah.
When you said 21.8, I figured what you had done. Yeah, we got to start with the 2 times 2, class. 4. And that actually works out really nicely because 9 minus 4 is 5. And so that whole thing becomes a 5 over a 5. Now, we also, after we're done with grouping symbols, we'll take care of our exponents. So let's do it, take care of the 2 squared.
4.
And by the way, technically, because it's not connected with that over there, we could have done that first. It wouldn't hurt anything. The key thing to remember is that the last thing we do, always save what for last, class? Add and subtract, right? Unless it's in parentheses like we saw here. Always add, subtract last. So I'm not touching this addition. I'm not touching this subtraction. I'm not touching this addition. Now I'm going to do what 2 processes, class? Multiply, divide. I'm going to take care of the multiplication. I'm going to take care of the division. So 14 times 2, class? 28. Careful. And then the 5 divided by 5. Remember, that's what the fraction bar means. 1. And now we can go in order. 4 plus 28.
32.
32 minus 13. 19 plus 1 is 20. And there's our answer there. All right, questions on that? Questions on that? That was a challenging problem. Flip back, if you would, to page 45. At the very bottom of the page, underneath the picture of the, I don't know if that's apple pie or peach pie. Kind of looks like a peach pie. I don't know. Anyway, underneath the picture of the pie, just to make you hungry, do 44 to 47. 44 through 47 there at the bottom of page 45. And then we'll get back into our discussion of fractions. Let's do a little bit more GCF, LCM, and order of operations practice. Good, several people already done with the classwork. Tell you what, I've got the camera aimed up at the ceiling here now, so let's have, Jalen, you're finished? No, you're not. Michael, you're finished. Michael, come to the board of the GCF and LCM for 4 and 12, the first problem. Are you finished, Ben? Keep working. Are you finished? Yes? Come up to the 20, 12, and 20 GCF, LCM. Are you finished? Take the first order of operations. Are you done yet?
Can I do the second?
Are you finished yet?
I did the second one.
Well, I'm going to wait till you're done with all of them. Wait till you're done with all of them. Anyone else finished with all of them? Just erase it right there next to you. I guess what I was counting on was a list there, Michael. A list of factors next to the 4 and 12, but that's okay. Just kind of put down. Corey, question or finished? Can you do the second order of operations problem? All right, next one to finish gets the last one at the board. What do we do for LCM? We mark. For the sake of time, I'm going to put your pencils down, look this way, and let's see if I can get the camera readjusted here a little bit. There we go. All right, let's take a look at the work that our students did here. And Michael did his prime factoring here, and he found his GCF right off, and then he kind of erased it to make room for his LCM. So on what he originally had, of course, for his 4, he prime factored into 2 times 2. His 12, he prime factored into 2 times 2 times 3. He noted that there were a pair of 2's that were common, which gave him a GCF of 4. For his LCM, he said, well, these 2 2's and these 2 2's, that's a tie. So like, well, I'm going to pick that one. Cross out that one. That's a loser. And the 3, that's a winner because there's no other 3's. So 4 times 3 gives 12. And so 4 was the GCF and 12 was the LCM. How many got that GCF, that LCM for 4 and 12? The numbers themselves were our answers. For 12 and 20, Elaine's problem, she prime factored the 12 into 2 times 2 times 3 and the 20 into 2 times 2 times 5. Well, again, they both have 2 2's. So the GCF is again 4. For the LCM, she said, well, these 2 2's are the winner and these 2 2's are a loser because that's just what she picked, even though technically it was a tie. There are no ties, she breaks the tie. There's a 3 that's winner here, there's a 5 that's winner here. When she multiplied all that together, she got 60 for her LCM. How many got 4 and 60 for the GCF and LCM respectively? All right, questions on those? Let's take a look at the, make sure you have your book open so you can be checking your answers. On number 46, 45, this was Paige, no, who did this one?
Paige.
That was Paige, yeah. I was looking for some like hand or something. Okay, Paige did this one here. And she started off with the exponent. A little mistake on the exponent though. What's 3 squared? Not 6, it's not 3 times 2. What does squared mean?
9.
Right, 9. So 3 times 3. So that's going to change your answer just a little bit here. So with a 9, that gives you then a 12 minus, the 6 would have been a 6 plus the 18 would have been a 24. But otherwise, you followed the order of operations really well. And the mistake she made, by the way, it's not the first time. In fact, I saw that on some tests. Right? Be careful. Not 3 times 2, 3 times 3. How many did have 24 for your answer? All right. Anyone make the same mistake Paige did? You got 21? Yeah, okay, be careful. All right, Paige is not alone here. We had a 3 squared again. This time, whose was this? Corey. Corey remembered 3 squared was 9, so we got that here. Solved within his parentheses to get 3. Did the multiplication before the addition, got 26 for his answer. How many had 26 for number 46? And number 47, I've got one grouping symbol right here. I've got to take care of the 5 minus 1 class. 4. So I've got a, I'm going to just cross that out and put a 4 here. And so I've got a bunch of multiplications, and I've got, what does that fraction bar mean, class? Division. So 6 times 4 times 2, anybody?
48.
48. I'm going to keep the minus 12 and plus, but here 4 divided by 2, class? 2. What is 48 minus 12? 36 plus 2? 38. Our answer for 47. How many had that? Those who made it to the last problem. Questions on that classwork? All right, now I want you to look further up the page, and yesterday we did all of the odd problems, 27 to 41. I want you to do 28 to 42, the evens. 28 to 42, the evens now. Just reducing fractions to lowest terms. The key, don't stop reducing till it's completely reduced. So if there's anything else you can divide out, make sure you get it out. Divide top and bottom by the same number. Ideally, the GCF. Just we're too lazy to find the GCF first. Once you finish, put your pencil down, look this way so that you're done. Did you work ahead? You just did them that fast? Wow.
Wait. Oh,
Ben, did you work ahead? I was going to give candy for the first one done with all the right answers, but if folks work ahead, I can't do that. So make sure you're not working ahead, okay? Don't be working ahead. Wait till I assign something before you do it, because I've got a reason I'm not assigning it yet. You know, if I've skipped it, there's a reason. Really? Okay, even despite being hit yesterday. Good. I'm glad it's not hurting. I was thinking about that last night. It's like, what are we doing? Good. You still got the compression sock on today?
I forgot to put it on.
Can't even hurt too bad then. That's good. A few people already finished. Take another minute. 1 more minute to be finishing up. Think through your divisibility rules as you try to reduce them down. Last one's fun, isn't it? All right, let's take a look at these together. Most of them weren't too bad, though that last one, last couple actually, were a little annoying. Let's see here. Number 28, what did you get for your answer, Sam?
6.
Ooh, not 1/6. We should divide a 3 out of the top and bottom, right? 3 divided by 3 is 1. What's 9 divided by 3? 3. Not 9 minus 3 to get 6, but 9 divided by 3 to get 3. So 1/3 should have been our answer. How about number 30? What did you get for your answer, Paige?
1/3.
1/3 again. How about number 32, Griffin?
1/4.
1/4. Number 34, Elaine.
1/5.
1/5. Number 36, Jalen.
1/16.
Careful, you're dividing top and bottom by 16. So again, don't subtract the 16 in the bottom. 32 divided by 16 equals, Bryson? Ooh,
1/2.
1/2, right? Now, I will say this, technically, yes, you should divide top and bottom by 16 to get your 1/2. Most of us probably aren't thinking 16 times tables here, but most of us might see an 8, perhaps, right? Or at least a 2, right, to get 8 over 16. Then from there, we can divide the 8 to get the 1/2. So you don't have to get the whole greatest common factor right at the beginning if you're not seeing it. Let's come back to Jalen for Redemption 38. Number 38, Jalen?
1/2. No.
What did you divide out of the top and bottom here, Jalen? What number do you see that can be divided out? Forget your work, just look up here at the board. What can we divide out, Jalen? Look it up this way.
8.
Divide an 8 out, okay? If I divide out 8, what do we get?
3.
And here,
4.
there we go, 3/4. Should have been our answer there. Number 40, this was a fun one. What did you wind up with for your answer, Michael?
I went to do 1/3.
1/3 ends up being your answer. Now, most of us do not know our 26 times tables, right? But we should at least see they're even. So we can at least divide a 2. How many of you just started with a 2? So get the 2 out, and you get your 13/39. Now from here, you might actually see, hey, this is 3 times 13. So if I divide out a 13 from both of them, I get 1/3. Anyone see 26 right off? You're like, yeah, 1 times. Wow, several of you did. Good. Look at the last one. We had a 52/65. And if you're thinking through your divisibility rules, you got nothing, right? What is the common factor, Ben?
2.
Well, 2
No,
doesn't go
5.
into 65, but 5 doesn't go into 52. You said you were done. Bryson? Well, no, there's something bigger than 1 that can be divided out. Jalen?
3.
No, because neither one of them is divisible by a 3. Okay, Michael.
13.
It's a 13. You say, Mr. Stafsky, how am I supposed to get that? If you can't figure it out, look at this way. This is the only time I recommend prime factoring, is if you got no clue. Well, you know this is at least 2 times 26, and that's 2 times 13. You at least know there's a 5 in there. It's 5 times, 13. Now watch, is everybody looking up this way? It's not all lost either, because see what this is? This is 2 times 2 times 13. This is 5 times 13. If you scribble out the 13, what do you have in the top class? 2 times 2, which is 4. And in the bottom, you've got, well, 5. And you already have it reduced. So if you prime factor and scribble out all the matches, what you're left with is your answer. And so we do get 4/5. How many besides Michael? You got 4/5, right, Michael? Anyone besides Michael get 4/5 for the last one? Okay, question.
I got a 2/13.
That's not 2/13s, it's 4/5. All right, we need to move on. Turn the page. Turn the page. Actually, turn over a few pages here. And we're going to begin looking at adding fractions. If you look at page 51, there's a whole bunch of fractions you're going to add here in just a moment. For now, though, how about some blank paper, or scratch paper at least. It doesn't necessarily have to be blank paper. I need you to jot down some key things here. When you add or subtract fractions, there's something that your elementary teacher should have emphasized to you. There's something you have to have, class.
Common denominator.
Common denominator. Write that down in the side margin at the top of page 51. You have to have a common denominator. You can't add or subtract without it. Okay, gotta have a common denominator. Now, if you were to see something like this, and you could jot this down on that scratch paper, 1/5 plus 3/5. It's super easy. You literally add the numerators, class. 1 plus 3, 4, and you just keep the denominator. Do not add 5 plus 5. keep the 5. The whole point in having the same denominator is so you can keep that same thing. Think of a fifth as an object. I don't know, maybe a piece of chalk. I'm too lazy to actually, a pen, there we go. All right, so if I have 1/5 in my hand, and this hand has 3 more fifths, what do I have? I have 4 fifths, whatever a fifth is, okay? So you just add the numerators, keep the denominator the same. Write this example down on that blank paper. 5/9 minus 2/9. Kind of the same thing except it's subtracting. You subtract the tops, class 5 minus 2, and then you keep the bottom the same. So we're going to keep 3/9, except we always, class, reduce. And what does 3/9 reduce to? 1/3 as we divide the 3 out of the top and bottom. Make sure you have that example written down. So what happens if you have something like 3/4 plus 2/3? They don't have the same denominator. This is where the LCM comes in. You've got to change the denominators. The 4 has a lot of different multiples, class. I could turn 4 into 8, 12, 16, 20, 24, 28, 30. You get the idea? I could turn 3 into 3, 6, 9, 12, 15, 18, 21, all those different numbers. What number is on both lists without taking the time to prime factor, class? 12. We could turn the 4 into a 12 by multiplying it by 3. And remember making those equivalent fractions? What you do to the bottom? So we're going to multiply the top by 3. 3 times 3 is? 9. Well, down here I've got to turn the 3 into a 12 also, but that means multiplying it by 4. Which means I've got to multiply the top by 4. 2 times 4 is? 8. Do we remember doing this in elementary school? Turning a 3/4 into, for instance, 9/12. 2/3 into 8/12, and now we can add, just like we added here. It's really 1 plus 3 is 4, and then keep the 5. Well, here, class, it's going to be 9 plus 8 is? 17, and then we keep the 12. But we don't leave the improper fraction. How many times can 12 go into 17? Once with how many left? 5. So we're going to leave our answer as 1 and 5/12. So make sure you have this written down on that scratch sheet of paper. Doing this along with me. One more to get done with me. Write this down. 2/5 plus 3/10. Write that down on your scratch paper. 2/5 plus 3/10. Again, in order to add or subtract, class, you have to have a common denominator. Actually, I meant to have a minus right here. Let's make that 2/5 minus 3/10. That's a glitch in my notes. Gotta have a common denominator. And right now I ain't got one. So we're going to look at the 5, we're going to look at the 10, we're going to ask ourselves, selves? What can both 5 and 10 become? What is a multiple that they share?
10.
Class? 10. Oh, careful, not 5.
10.
You can't make a 10 become a 5. You can make them become bigger, right? Multiples are bigger. So we're going to make them become bigger. But I can leave the 10 as a 10 and then also change the 5 into a 10. What if you said 20? Could I make them 20?
Yeah.
You could, but then you're going to have more work on the back end. We're lazy. We don't want to do more work. So we're going to try to get the least common multiple, which is 10. Did I do anything to this 10, class?
No.
So do I do anything to the 3?
No.
Because what I do to the bottom, I do to the top. And if I do nothing to the bottom, I don't do nothing to the top. Leave it at 3. Or you could say, technically, could we multiply by 1? I'm too lazy for that. Just leave it alone. In the top fraction, class, I got to multiply the 5 by
2.
to get the 10. So if I multiply the bottom by 2, gotta multiply the top by 2. Good, Griffin. And that's going to give us, class?
4.
So 4/10 minus 3/10 equals
1.
1/10. Again, subtract the numerators, leave the denominator alone. Questions on adding, subtracting fractions. We remember this from our elementary days? Can I have you try some of these now? On page 51, do 2 through 12 the even. Do just 2 through 12 the even on page 51. If they already have a common denominator, yay, that makes it easy. We're lazy, we like that. If there's not a common denominator, make it common. Change the denominator and the numerators then with them to do the addition or subtraction. 2 through 12 the even. gonna do this in just a little bit. We're gonna go over these answers first. Several people finished up already. And just doing the evens, 2 through 12. All right, for sake of time, pencils down. Even if you're not finished with all of these, that's okay, pencils down. Let's see how we did. Number 1, 1/8 plus 3/8. Initially, class gives us 4/8. Careful, don't add those 8s, just 4/8. Oh, sorry, number 2, sorry. We did the evens, not the odds. Rewind. All right, then number 2, let's take a look at class. When we add 7/9 plus 5/9 plus 2/9, initially, class, we get 14/9. But we've got to change that, Corey, to say
1
and.
yeah, 5/9.
1 and 5/9 is correct. Number 4, we got 32/36 minus 8/36. Initially gonna give us what, class? 24/36, but we gotta change that page to say,
3/4.
ooh, not 3/4, Jalen.
14/36.
Should have been 24/36. Then we reduce it down, Elaine.
2/3.
2/3, right? 24/36, if you divide the 12 out, 24 divided by 12, 2, and then 36 divided by 12 is 3. So 2/3 should have been our answer for 4. Number 6, we don't have a common denominator yet. We've got to change the 1/2 to say what then?
1.
Ben, number 6, the 1/2, you changed it. What does it say now?
4/8.
And then you can add the 3/8 plus 4/8 to get
7/8.
7/8. There we go. Number 8, we had to change that 1/4. We had to make it say what? Paige, back to you. 2/8, and 5/8 minus 2/8 gives us
3/8.
3/8. Very good. Number 10, both fractions have got to change. Now there's a shortcut to doing this, and there's the long cut. What did you change 6/8 into, Jalen?
18/24.
You could. 18/24 should be fine. And therefore you changed the 3/12 into
6/24.
6/24. So when you subtracted 18/24 minus 6/24, it gave you
1/2.
12/24, which became a half. Or, did anyone notice that 6/8 could reduce down to 3/4, and 3/12 could reduce down to 1/4, and you could actually subtract to get 2/4, which becomes a half. We don't normally get to do that. Normally it doesn't work that way, right? Normally, you'd have to go with the 24 from the 8 and the 12, but this time it actually happened to work that way. How many went with the 24s, like Jalen did? That's the conventional way to do it. Number 12. We had to blow that 1/5 up a little bit bigger, make it say what, Michael?
Like the answer?
No. Number 12, the 1/5 they gave you, you changed it to say 3/15. Then you subtracted 1/15 to get
1/15. I mean, 2/15.
2/15 is our answer there for number 12. All right, anyone perfect? 6 for 6 on those. You got them all. Any questions? I talked through them. Do we need to see them worked out on the board? Anybody need to see worked out? Yes, sir.
I have a question.
Question?
Are we gonna be reducing fractions yet?
We already did that.
I mean, not reducing, but borrowing.
In a minute.
That's what that
Patience. We're getting there. All right, let's go ahead and take a look then at the board. And really nothing different too much here, but we want to work with mixed number addition, subtraction as well. Probably going to keep you just a hair past the bell, so when the bell rings, just ignore it. Let's keep on rolling here. Basically, if you've got the common denominator, class, you just add. 4/5 plus 3/5 class is 7/5, no big deal. But we also have whole numbers as well. That's what makes these mixed. We also have the 3 plus 2 class. 5. But just like earlier, we wouldn't leave it improper. We're not going to leave it here. The 7/5, class 5 goes into 7 how many times? Once with 2 left over. The difference is now this 1 has to be added to the 5 that's already here. So our answer becomes class 6 and 2/5. Do you remember that from elementary, adding the mixed numbers? So when you change to the mixed number, add on the whole number part to whatever the other whole number was. Here, ignore the whole numbers for a minute. Let's just get common denominators. I've got a 6, I've got a 3, I've got a 9. What can 6, 3, and 9 all become? What's that LCM, Griffin? 18. How many thinking 18 like Griffin was? So you gotta change them all to say 18. Now here, class, top and bottom have to be multiplied by 3. So 1/6, Sam, becomes 3 18ths. Here, class, we gotta multiply top and bottom by 6. So that 2/3 becomes, Bryson, 18ths is correct. And then the 4/9 gotta multiply top and bottom, class, by 2. So that Luciana, my 4/9 becomes 8 18ths. By the way, what is 3 plus 12 plus 8 gonna give us, class?
23.
23 over
18.
18. Now, if you wanted to, you could change it first. Instead of waiting till the end, we could say 18 goes into 23, class. Once, and I can put it up here with how many left? 5. So I could make this a 5 18ths, and I could go ahead and carry the 1 at the beginning. And then 1 plus 8 plus 5 plus 6.
20.
And we get our answer of 20 and 5 18ths. Are there questions on adding mixed numbers as far as when you get the common number, when you get your improper fraction, carrying the whole number up? Any questions on that? Look at this next one though. This is what Michael was asking about. I got 25 and 3 11ths minus 7 and 7 11ths. Class, can you take 7 11ths from 3 11ths?
No.
No, you can't do that. If there is a pizza divided into 11ths, and there's only 3 slices of pizza left, can you take 7 of them?
No.
But what if you really, really want 7 slices of pizza? Do you know what you do? You open up another box that has all, let's say that's 11 slices, that has all 11 slices in it. Now how many slices are available to you, class? These 3 plus those 11 gives you what?
14.
There are now 14 slices available, but you've got to open a new box, right? You've got to borrow from the 25 whole number. That's 25 whole pizzas sitting there. You're going to borrow one of those. So now how many pizzas are still here, class? Ignore it. Stay with me.
24.
24. And that one whole pizza has 11 11ths, right? Now, it doesn't have to be 11 11ths. It could be 8 8ths. It could be 2 halves. It could be whatever you want it to be as long as the numerator and denominator match, right? But in this problem, I want 11ths. So it's 11 11ths. And I'm going to compare the 11 11ths with the 3 11ths to make 14 11ths. Now we can subtract, class. 14 11ths minus 7 11ths. 7 11ths. And 24 minus 7 is 17. Stay with me. Here, we've got to get a common denominator, don't we? 6 and 8. Probably the best denominator is 24. So let's change them to 24s. Here, multiply top and bottom, class, by 4 to get what, Corey?
4.
4 24s. Here, class, multiply top and bottom by
3.
to get what, Jalen? 9 24s. Class, can I take 9 24s from 4 24s?
No.
So I'm going to have to borrow, just like we would any other time. We're going to borrow from the 31, and it becomes a 30. But the one that I borrow could be written however I want. 2 halves, 3 thirds, 4 fourths, 5 fifths, 6 sixths. But what do I want the denominator to be?
24.
So what does the numerator have to be? 24. I'm going to borrow 24 24ths. Does that make sense? When you borrow the one, it's however you want as long as they match. Now, I already had 4 24s sitting here. I just borrowed 24 more 24s. How many total 24ths is that, class?
28.
That is now 28 24ths we got sitting here. Now we can subtract 28 24ths minus 9 24ths. 19 24ths. And now we can subtract 30 minus 12. 8, and then borrow 18. There we go. 18 and 19 24ths. One more example to show you. Can I take 4 ninths from nothing?
No.
So I have to borrow. Make the 3a.
2.
And the one that I borrow, how do I want to write it this time?
9.
I want to write it as 9 ninths. I can write it any way I want as long as they match, and I happen to want ninths this time. So it's 9 ninths. 9 ninths minus 4 ninths, class. 5 ninths. And 2 minus 1. 1. You're going to be doing a little of this in your homework. I'd hoped to have time to practice, but we are out of time, so we're going to have to call it there. Homework for this evening is to do pages 54 to 55. Pages 54 to 55. Do numbers 1 through 24 in the homework section. Pages 54 to 55, do 1 through 24 in the homework section. Have a wonderful rest of your day, and you are dismissed.